we've got a uniform distribution right here. So I know that the probability of each individual situation is going to be equal. From A to B, so it looks like I have 10 slots here from A to B. 35 minus 25 was what I did for that. So I have 10 set between. So I'm just going to do 1 over 10 for my probability of each thing happening, each minute happening. And so that's my probability. That's where I got 1/10. And then this lasts anywhere in between 25 to 35 minutes. So that is the function itself. Now looking at the graph, I chose the one, of course it's uniform, so it goes straight across. I wanted the one that went straight across at 0.1 and was between 25 and 35 minutes. I went and got the other parts of this problem. The first one was, what's the probability that the time preparation exceeds 30 minutes? So that's exactly in the middle, but in between 25 and 35. And with everything being equally likely, I said that, well, that's 0.5. What's the probability that the preparation time is within 3 minutes of the mean time? So what that means is if the mean time is, let's see, let me draw a little picture here. If the mean time right in the middle is 30, and we want 3 minutes on either side, here's 35, and here is 25. That means I wanted at, say, 3 minutes on this side would be 27. 3 minutes on this side would be 33. Everything being equally likely, I'm just counting 1, 2, 3, so that's 0.3, 0.4, 0.5, 0.6. That was why I wrote 0.6 on this one. The third one, anytime between A and A plus 3 minutes. So all you're doing is saying anytime in between there, 3 minutes, 0.1 for each minute, so that would just be 0.3. In problem 2, they told me that I had a normal distribution, so I'm going to use normal CDF from my Texas Instruments TI-8384 calculator. I believe the book shows you how to use your charts. You can use those as well, but for our purposes, the calculator is what I'm going to be looking for, making sure that you can plug these into the calculator. If you can do it with formulas and charts, that's great too. Just gives you more options. Since it's a normal, they tell me that I need to find the probability that my value for my standard normal is between 0 and 2.62 standard deviations. Now, if you've done your project worksheet, which I recommend doing that before you do these problems, you can see where a standard normal comes into play. Alright, I've put a standard normal up here, or somewhat of a standard normal, just so we can kind of get some idea of what this is talking about. If this is your mean right here, and my mean for a standard normal would be 0, then we have one standard deviation away from the mean, and right here would be -1. And at this area we would have 2 standard deviations from the mean, and over in this area, -2. Of course, this is not to scale. I know you think this is a lovely drawing, but it is not to scale. What they're asking me for in the very first case is the probability that my value is between 0 and 2.62 standard deviations away from the mean. So as you can see, if I'm looking at that probability, and probability is also known as area under the curve, so 2.6 something would be right around in here, you can see that it's almost half. And when I plug that into my Texas Instruments calculator and do what's called plugging that into my calculator, I would key second, distribution. I would scroll down to normal CDF, and then the Texas Instrument makes you put in your entries in this format. You need the lower entry first, then the upper, then your mean, and then your standard deviation. The newer calculators actually have the words for you, which is very nice. The older calculators, you just have to know that this is the syntax. I would write this on a note card so that you would know what your syntax needed to be if you had an older Texas Instrument calculator. But my lower limit obviously would be 0 right here. My upper limit, 2.62. My mean, because it is a standard normal, it's in the Z format, the mean would be 0 and the standard deviation would be 1. So on my test or piece of paper, whatever you want to write down, I would write normal, CDF. If you're wanting partial credit, so just in case something gets keyed wrong, or maybe the decimal points, because sometimes these decimal points differ, whether you're using a chart or a TI calculator, or whether you're using one of the software packages. Mean is 0, standard deviation is 1. Key that into your calculator and you get the 0.4956. The next problem is very similar. They're asking you for the probability that your mean lies between 0 and 2 standard deviations. So after working your worksheet, you would know that this area in here, this first standard deviation would be at 34%. This standard deviation here would be at the 15.9 roughly, and when you add those together you'll end up with the 4772. I probably would just use the calculator to get that value. Just once again plug it into the normal CDF. For problem C, once again, normal CDF, lower limit negative 2.7, upper limit 0. The mean, because it's a standard normal Z, is 0. Standard deviation is 1. Let's look at D. That one's kind of interesting. Negative 2.7 standard deviations away. That's way down here. Going all the way up to 2.7 standard deviations away. And almost the whole thing is shaded in. And we know that the area underneath the entire curve is 1. So you can see when you plug that into your calculator, you got 0.993 as your probability, which makes a lot of sense. E is the question that I wanted to look at next because it wants to know the probability that Z is less than 1.22. For your lower limit, that would be negative infinity. To tell the TI calculator to do that, you would write normal CDF. Then you're going to key negative 1, and then you'll need to hit Shift and then an EE key. And what will pop in there is this E that looks like this. So I need to describe what this key looks like. So that means that's your times 10 to the button. You could actually key in negative 1 times 10 to the 99th, but this particular feature makes it a little bit quicker. But what you would hit is second. And then there is an EE key. It's 2 capital E's, and it is right on your comma key. So if you would like to use that so that you don't have to key times 10 raised to the 99th for that one, it'd probably be easier. Your upper on that one is 1.22. Once again, your mean is 0, standard deviation is 1. Key that in and you'll get that value there. And then F is very simple. Okay, problem number 3. What we're given is the area under the curve, and we're to give the percentile of the following. So, area under the curve, inverse. And this is, of course, once again, second distribution on your calculator, inverse normal. Above is the syntax for your calculator. Newer calculators will have it written for you, which is very nice. The area is 0.71. This is a standard normal, so my mean is 0 and my standard deviation is 1. And this is my probability, or my area under the curve. and it is at 0.55 on my percentile. So I can have some sort of frame of reference for what this looks like. The 71st percentile, that's the area under the curve, so 0.75 would be right around in here and back, and about 75% of this or 71% of this is shaded, and this happens at 0.55 standard deviations away from the mean. The 29th, you're going to say that the area is 0.29. Nothing really changes. It's just doing the same thing over and over, but at 0.29, that would be over in this area, and the standard deviation on that would be at 0.55, negative 0.55, and that would be your percentile. This problem is similar to the two previous, but the mean and the standard deviation, these aren't standards. It doesn't really matter to us with our TI 8384. The calculator will take care of those issues for us. It says, what's the probability that yield strength is at most 40? So that would mean at most 40, it means 40 and below. So my lower limit on that one, I would be doing a normal CDF. And then my lower limit on that would be the negative infinity, which is -1, shift, EE, whoops, but only an E pops in there, 99. I'll just write it like that. Negative infinity is fine, place in there, but your calculator won't take it, but if you're writing it to me, just put in negative infinity. 40. The mean on this, they give it to me, is 45. Standard deviation is 5.5. Just plug that in your calculator, you'll get the answer greater than 67. Once again, normal CDF. 67 is your lower bound. Your upper bound is infinity. Just key 1 times 10 raised to the 99th, and then 45, 5.5. Nothing really changes on that one. B part is a little bit tricky because they ask you separates the strongest strongest 75%. So what they really want, even though they don't say it, here's the weak 25% and the strongest 75%. What I really want is this 0.25 area and not the 0.75 area, which was very tricky of them to do. Inverse normal. So I want the 0.25 area, and you just key in the mean and the standard deviation. And that pretty much concludes Chapter 4 problems. If you want me to work anything else, just send me a message and I will.